Hey guys, Doug here with your week 6 MyStatLab problem 10 example. In our problem, a poll asked a group of people if the fact that they make copies of songs on the internet for free made them more likely or less likely to buy a performer's CD. Only 18% responded that it made them less likely. The poll was based on a random sample of 751 internet users. Part A of our problem asks us to check the assumptions and conditions that are met for inference on proportions. So let's take a look. First one is independence assumption. Well, the poll was based on a random sample of internet users, so there's nothing there to state that the independence assumption is not there. The second part, randomization condition, it tells us that it is a random sample. So let's say that that's okay also. We're going to move on to the fourth condition, 10% condition. Sample size cannot be over 10% of the population. Well, I don't think 751 internet users is over 10%, probably a very small percentage from there. And then our last condition is the success failure condition. So we have to have both NP hat and NQ hat to have sums that are greater than or equal to 10. So let's go ahead and make that calculation. The given sample estimate of the true proportion, or p hat, as given in the sample here and given in our problem, is 18%. So p hat is going to be 0.18. So now we need to calculate q hat. And we know that is simply 1 minus p hat, so we can say equals 1 minus p hat. Enter that, and our q hat is going to be 0.82, and then our n, which is our sample size of 751. So now we can calculate our n times p hat, n times q hat. We'll start with p equals n times p. Enter that at 135, and then our n times q is going to be equals n times q. Enter that, and there we have both of them much greater than 10, n p hat at 135, n q hat at 615. So now let's go ahead to part B and find a 95% confidence interval for the true proportion of all internet users who are less likely to buy CDs. So we're going to find the upper and lower bounds of a 1 proportion Z interval, and we're going to use the formula that p hat plus and p hat minus our Z score times the standard error of p hat. So let's look at what we have here. They gave us a table with confidence intervals of 90, 95, 98 and 99%, and their z-scores that go along with it. Since we are asked for a 95% confidence interval, we know we're going to use 1.960 as our z-score. We also need to find the standard error of p hat, and for that we're going to find the square root of p hat times q hat over n. That will give us that. So let's go ahead and create that formula here. And we can start typing equals, and since this is the square root, we'll start typing square root, and there it comes right there. So now all I do is fill it inside the parentheses, and I'm going to use two sets here. So the top part of p hat times q hat, so p hat times q hat, I'm going to close those parentheses, divided by n, which is here, and hit enter. And there we have it. There's a standard error of p hat at 0.14019. And we can go ahead and calculate the lower and upper bounds now that we have everything we need. We have our standard error, we know what p hat is, and we know what our z-score is. So for our lower bound, we're going to say equals, using our formula here, p hat minus our z-score times our standard error, enter, and there is our lower boundary at 0.153. We can also calculate the upper boundary using the same formula, equals p hat plus our z-score times the standard error again there. Hit enter, and there we have our upper bound at 0.207. So we can say the 95% confidence interval is and it's 0.153, comma, the upper boundary 0.207, and there you have it. There is our 95% confidence interval, and that's it. That's all there is to week 6 MyStatLab problem 10 example. I hope this helps, and we'll see you next time.